Hey, what's up? Welcome back. This is day 9 for the advent of code. We're going to be solving this with Ruby. The problem today is called smoke basin, and the idea is that you want to sort of like find these low points in a map. And so the map is given to you as a height map. They call it a height map, where each individual number on the map represents the height of that area. And so if you find a point where the values are, it's the lowest point in that area. So in this case, we have a 1, right? Because that's the lowest point of all of the surrounding numbers. So in this case, we're only considering the numbers directly to the left and right, and directly up and above and below. And so we've got several different low points here. We've got a 1, a 0, a 5. This is a low point because all of the points around the 5 are higher values, right? So the 8 is higher, the 6 is higher, the 8 is higher, the 6 is higher. And then we've got another 5 where it's surrounded sort of by 6s here. And the first point, or the first goal, is to find all of the low points. And so let's go ahead and try to figure that out. So we're going to open up we'll make another directory here, and we'll call it day 9. And here I'm going to call the actual class heightmap.rb. And in here we will have our class heightmap. And we'll figure out what that's actually going to look like once we have day 9 spec.rb, once we have some tests here. So require relative / day 9 heightmap.rb, RSpec describe heightmap. So the first thing we want to do is, I guess we want to figure out like if a specific point is a low point. It like I guess we want to like, this is going to be a method we want to write, so we can describe maybe low point, and it like returns true if less, or if like, yeah, smaller than neighbors. Okay, so then we want like some map, which is heightmap.new, and it's going to take in some values. So like, why don't we just start with sort of this corner up here, and we can sort of be a little bit, yeah, so 219. So we'll do 219. And then what is the other? 398, 398, and then 985. So 985. And we want to expect that map.lowPoint of 0, 1, so like 0, 1 being the coordinates of that position, to be true. So we want to be able to just like pass in a low point and get back whether or not it is a low point. And so we need to make some method here that takes in a grid, I think. Grid, and then we want to make a method here, low point. That's going to take in some point. Okay, and then expected nil, but you want that to return or like respond to true or be truthy. Perhaps you meant be true. Huh? Expect. Oh, yeah, I guess like I want this to be like be true. Yeah. Okay, we expected true, we got nil. All right, so is it a low point? So in order to figure out if it's a low point, we need to know like the values of the neighbors. So I guess we should make a method neighbors. So let's also do that. Neighbors. And the way we're going to figure out our neighbors, it like returns the coordinates for the neighbors. And I guess we want to say like map.neighbors of 0, 1, and we expect that to come back as actually, so for when we're this is going to be an array of arrays where each element in the resulting array is a coordinate. And yeah, so this is going to be something like the neighbors for 0, 1 are going to be 0, 0, 0, 0. And I guess the one right below it. Remember, we're only going left, right, up, and down. We're not going diagonal. Okay, so then the one right below it here, this is value 1, or this is like 1, 1, position 1, 1. Okay, and then this value here is going to be 0, 2. 0, 2. So that's what we expect to come back as the neighbors. And we have no method neighbors, so let's make that def neighbors. And that's going to take in some point. And then we want to calculate what are all of the neighbors from that point. And I guess we can destructure this into like x and y. And here the neighbors are going to be x and y minus 1. X and y plus 1, and then x minus 1 y, and x plus 1 y. And then when we're looking at a point, like if the point here is 0, 0, then we might end up falling off of the edge of the map, like in the negative direction. So we want to make sure that these neighbors are actually valid based on our grid. So what we want to do now is like select out the neighbors where they're valid. So then this is going to be like another like A and B or I and J or something. Let's do I and J. And we want to select where I is between 0 and grid.length plus 1, maybe, I think, and J between 0 and grid.first.length plus 1. I think that's what we want. I don't know. We're going to see. So we'll run this and all right. So we got back 0, 0, 0, 2, 1, 1. And that is actually the values that we care about. But because I'm using EQ here as part of RSpec to make this assertion, it assumed like EQ is making sure that the ordering and the elements are both exactly the same. So I can change this from EQ to contains exactly, I think. Let's see. RSpec contains exactly. Yeah. Okay. And then I think that should work. Containing exactly, to contain exactly. I don't know. Okay, that works. All right, so then let's also make sure that we don't fall off the map if we try to check out the value of 2, 2. So let's get the neighbors for 2, 2, and we should get, what is it? 2, 1. 1, 2, and that's it, right? Just this one and this one. So that should also work. What did we get? Okay, so we don't want 3. We don't want 3. So this something here is off. So maybe our length should not have been length. Let's see. Expected 1, 2, 2, 1, but it actually got 1, 2, 2, 1, and 2, 3. Yeah, we should be filtering those out based on this thing. So the grid length is, in our case, the grid length is 2, so it should be between 0 and 2, and J should be between 0 and 2 also. And why are we getting back 3s? We should not be seeing any 3s, right? That is odd. So let's add a by bug in here. And okay, so I puts J, puts grid.length, puts, oh, we need to do -1, not +1. Okay. All right, so this should be -1. All right, cool. I think that should work. Great. All right, so now we've got our neighbor situation working. Now we need to figure out if all of our neighbors are less than ourselves at a certain point. So inside of low point, we want to see if neighbors for the point dot all, if all of the neighbors are greater than, oh, that's just going to give us the coordinates too. So if the neighbors at that point are greater than our self at that point, then we want to return. And so the reason why I'm pausing here is as we're working on this 2D grid, it is handy to have these square bracket operators, X and Y, or maybe we take in, yeah, X and Y as a single value, and then we can say self or at grid at X and Y is going to be our return value. So here now we can say something like self at N. We expect that if the neighbor is greater than self at point, then it should be a low point. So let's see what we get. True. All right, let's add some more tests in here. So like 0, 0 should be false because 0, 0 is not a low point because it has a neighbor that is less than itself. Let's make sure this works. Okay, and then also let's check to see that 2, 2 is true. 2, 2 is true, and maybe also that like 1, 2 is false. And that should give us enough confidence that we're able to find the low point. Okay, so now we know how to find a single low point given the coordinates of a point. Let's iterate over all points, right? Like this wants us to tell us, in the above example, there's 4 low points, all highlighted, the 2 in the first row and 2 in the second row. Okay, the risk level of a low point is 1 plus its height. So in the above example, the risk levels of the low points are 2, 1, and 6. 2, 1, 6, and 6. The sum of the risk levels of all low points in the height map is 15. So I guess we want to like define some method like risk level or something, or like it calculates the risk level as expected. And in this case, we can let's just use this same map. Okay, so here's the thing, right? Like as soon as we start copying around these maps also, so we're using it here, we're using it here, we're using it here, and we're also using it here, right? One thing that we can do is we can use another feature of RSpec called let. So we can say let map do end, and this block just needs to return something. And that's what, okay, so we're basically creating a variable that's available in all it blocks, and technically it's a method. And now we can use map as if we defined the map inside of the block. Okay, so this is a feature of RSpec called let. There is contention about like whether or not you should use let, because some people say that let makes it more confusing, makes the test more confusing, because now you have to know to look up at the top to see where the variable was defined or how the variable was defined. But it can be handy. It can be like a handy thing to use. So I wanted to just show it so that you can see it, I guess. So here's an example, right? Like as I'm calculating the risk level, it's going to be important for me to like actually see what the values were in the map, right? And I can't see those from here because I'm at the bottom of the file. And so I want to like be able to look at this array here. So whatever. So like map, we expect that map dot risk level to equal, and it's going to be 1 plus the low point. So we have 2 low points in our example here. So we're going to have 2 plus 6, right? Because it's going to be 1 higher than whatever the height is there. So 1 plus 1 is 2. 5 plus 1 is 6. So we expect that the risk level here is going to be 8. And there is no method risk level, so we'll go define that, def risk level. And again, the risk level is going to be all of the low points. So I guess we need to figure out like a method low points to give us all the low points. So we'll iterate over all of the points, grid.each with index do row and I, and then row.each with index do cell and j, and then we'll just say like if low points is an array, and then we'll return low points. So here, low points, we'll shovel in ij if low point of I and j. So if it's a low point, then we get back a low points. And I guess the other thing, yeah, let's make a test for this too. It finds the low points. So we'll say expect map.lowPoints to equal or like to contain exactly 0, 1 and 2, 2. All right, that worked. And then finds the low point values, because we actually need the values at those positions. So we're expecting now that we get like 1 and 5, right? And we don't have a low points values method yet. So low point values, and that'll be low points dot map self at the point. Okay, and then we can do that. What do we get back? To contain exactly. Oh, we didn't change this thing. Low point values. Okay, so our risk level is still failing, but our low point values are working. So now we can have a risk level that is low point values dot map the value plus 1 dot inject plus, and we get back 8. Cool. All right, so now we're able to find the risk level at the point. All right, so now let's see what is the sum of the risk levels of all the low points in your heat map. I think that's what we've got. So cool. All right, so let's get our example input. And it looks like this, giant, giant map. Okay, and then we come over here, we add input, and we dump, dump it in. And then we're gonna go to the bottom and do this. So in order to get the grid, it's gonna be like file.readlines of argv.first.map chomp. So first we want to like chomp off the new line on the end, and then we want to split.map again, split that on, or like get the characters .chars.map to I think maybe this works. So like grid is this thing, p grid, and we will run this for day 9. Height map, day 9 input, and okay, we get a bunch of numbers. That's cool. So now we want to create a height map with these. Height map.new for the grid, and then we want to say puts map dot risk level, and just see what we get back. 585. Was that the actual value over here? 585. All right, that's part 1. Part 1 of day 9 for the advent of code solved with Ruby. So we've got this thing that figures out where the low points are. We figure out where what the sum of the risk values are. Part 2. All right, so next you need to find the largest basins so you know which areas are most important to avoid. A basin is all the locations that eventually flow downward to a single low point. Therefore, every low point has a basin. Although some basins are very small locations. Okay, so basically a basin is all of the positions near your low points that are not a 9. Okay, it's every position that's near low point that is not a 9. So all of our neighbors, we've got to like go through our neighbors and then go through our neighbors' neighbors until we hit 9s. And we want to just keep adding all of those points into the basin. So yeah, like starting from our low points, we know which specific points we need to start from, and then we need to find our basin points, or like, yeah, like all of the points related to a low point that are the basin points. All right, let's start by writing a test. So we come over here and we want to say describe, I don't know, basin points. And I think this is going to say like it finds coordinates of all basin points in a basin. Okay, so this is going to be something like map.basin points of, and then we're going to give it some point. So let's start with an existing low point that we know about. So here we'll start with the low point of 0, 1. So let's pass it 0, 1 and expect that it's going to give us back all of the points around that it's touching that are not 9s. So we expect that to contain exactly a bunch of points. So it's going to contain exactly 0, 0. It's going to also contain 1, 0. And I think that's it, right? So like or maybe it needs to also include itself. Yeah, 0, 1. Let's make it so that it includes itself. So that way we get the basin points that are in like this basin is this point, and this point. So let's see what we get. It fails because there's no method basin points. So def basin points. And how do we actually figure this out? Well, we need to go through our neighbors. And if the neighbor is not a 9, we want to add it to the basin points. But we also need to like search on from that neighbor. And so what I think we want to do here is actually create like a breadth first search type situation where we are like, yeah, okay, so we're going to start with like some sort of queue, which is going to have, we're going to start off with our point, with our self, basically. And then what we're going to do is say like, while the queue is not empty, we are going to pop something off the queue, queue.pop, and then we want to consider all of the neighbors of the point. And then if the neighboring point value is not 9, then we want to add it to the queue, right? Something like that. And then we also need to sort of keep track of it somehow, like keep track of the actual basin points, because this queuing mechanism is just like helping us with the breadth first search, but it's not actually keeping track of the points that are in the basin. So if self at n is less than 9, then we want to say queue dot, or yeah, we want to push onto the queue n. We want to push the neighbor onto the queue. And then I think we also need to keep track somehow of like what we've visited, which I guess can be the list of basin points. Okay, so basin points is this array. And after we pop something off, I think we want to put that in the basin points. Basin points. So we're going to shovel the point into basin points. And then we're going to iterate over all the neighbors. And then ultimately we want to return basin points. But we have a problem here, and I can't remember how we avoid. I think we need like, we don't want to add it to the queue if it's already in the basin points or something like that, right? So if it's less than 9 and it's not in basin points.include, and okay, so if it's not already in our list of basin points and if it's less than 9, then we add it to the queue to be considered. So we're kind of like building up this queue and then popping off of the queue as we work through it. I guess the other thing is that we can use the queue terminology here, push, or like, yeah, push and pop. Cool. All right. I don't know. Let's just give it a whirl and see what happens. No way. No. I don't trust you. There's no way. What? Not in one shot. This never works in one shot. Breadth first search. Something's got to be wrong. Are we doing this right? All right, let's try with some other coordinates because that feels wrong. Okay, so if we get the basin points for 2, 2, and if we look back over here just to double check, yeah, okay, huh. All right, so around this 5, it is just 8, 8. So around 2, 2, we should get 2, 2, and we should get 1, 2, and we should get 2, 1. What? No way. All right, we need a more complex map, I think. I don't trust myself. Whatever. All right, let's just play around and assume that this is actually working for a second. We might need to come back and write some more tests there, but whatever. All right, so find the 3 largest basins and multiply their sizes together. So the size of the basin is just like how many heights there are, how many measurements there are in that basin. So this top left basin is a size 3 because it has 3 things. All right, so then I guess if we've got all the basin points for a point, how do we find all of... Okay, so I guess we want to iterate over all the low points, find the basin points from those low points, and then we just want to add them all up. So something like def, what is this like terminology here? Sizes, I don't know, maybe like answer something. So the answer in this case is going to be expect map.answer to equal 6, right? Because there's 2 basins and each basin has 3 elements in it. So I think we want to say low points.map. We want to map each low point into its list, or it's like the basin point's length. So we want to map the low point, do LP. Okay, we'll be better. Low point. Map the low point onto basin points for the low point dot length. I guess we want to inject this, right? Because that would map it onto a new array. But we can actually just use inject here and say plus? No way. Is that going to work? No. Huh? What do we get if we just map it? Expected 6 got 3, 3. So I think we should be able to just say inject. Okay, we want to say inject 0 because we're going to start at 0 and we'll say ACC plus, and that should work. Cool. I guess the other way we could have done it is like map it and then inject, whatever. All right. So that is our answer for this really simple case. Let's see if we can get it to work for this example case here. And I also wanted to cover another feature. So Andrew Mason, one of the hosts from the Ruby Remote Ruby podcast, and so he was talking about how he used in day 1, he was using this data thing that you can do. So this is another cool thing about Ruby is you can just say underscore underscore end at the bottom, and that will make it so that you can read that instead. Let me show you what I'm talking about. All right, so the data that follows this underscore underscore end underscore underscore here is available inside of data. So you can say data as a constant dot each line dot map blah blah blah, and then like that should give us the same sort of thing. So we don't want the risk level. We don't care about the risk level, even though that was the right answer. What we care about is this answer 1134, and that is going to be find the 3 largest basins in oh wait, what? I did this wrong. Okay, we're not just adding up all of the sums. We need to find the 3 largest ones and then add that up. So this is answer. That is going to be the same, but whatever. Okay, so we find the 3 largest. So we do need to map this to the basin sizes. Okay, and then once we have the basin sizes, we want to sort, take the top 3, and then inject with, and then multiply them together? Okay, we're gonna inject with multiplication. All right. Let's just, no. What is this? Okay. We just want to call heightmap, undefined method -4 nil class. In answer, map, block, answer, basin points. Okay, so basin points. There's a minus in here somewhere. Somewhere we're calling neighbors and we're passing in nil. Okay, point. Why is it that? Oh, holy moly, this was confusing. All right, so I switched it back to map, but I didn't remove the accumulator. All right, figured it out. We were using inject before, which takes 2 arguments here, and Ruby was destructuring those instead of just passing them along. So, yeah, confusing bug when switching from inject back to map. So day 9 height map. Okay, so then those are the values. So we want to take the top 3. Well, .sort, .reverse, so that we have the biggest ones are at the top, and then take 3. So that should give us, yeah, okay, so this was the old one. We're dropping out the one that has 3. We're taking 19, 11, and 10, and then we want to inject that with the multiplication. And we get back 2090, which is the wrong answer. Okay, are we supposed to... Size of the basin. So the sizes are wrong. 19, 11, and 10. 19. There should not be 19. Okay, so let's go improve our tests here. So this is going to be like let example map do end. It's always surprising to me when I sit down to do these recordings too, how quickly I lose energy. Like talking and writing code at the same time. It's surprisingly requires a lot of energy. And my brain is like, why isn't this working? And there's probably something super simple. But yeah, just, okay. So let's see. So it calculates the answer for example map. All right, so we want to expect that the example map dot answer to equal, we want the example map dot answer to equal 1134. And when we run this, we get 2090. So we need to like work our way back. So expect that the example map dot basin points to contain exactly. Now this is going to take a second. So the basin points should be 0, 0. All right, let's make a new method called basin point sizes that'll return just part of this because we need to see the basin point sizes. Basin point sizes. So we expect the basin point sizes to equal the array of 3, 9, 14, 9. 3, 9, 14, 9. And we got 3, 10, 19, 11. So for some reason, our basin points are collecting more than it should. So now we need to like look at what those actual basin points are. Low point to figure out what's going on. So this first one is correct. So the 3, the one that's a 3, that one's correct. The 9 is the one that's wrong. So I'm wondering, like part of me is thinking, oh yeah, here we go. We have a duplicate. We've already got that number in there. All right, so what I think we want to do is we need to improve our basin point, this thing, so that we only add things to the basin point if they're not already in there. So if basin points include point. If they don't already include the point, then put them in there. Let's see. Okay, we got nil that time, but at least the first part is passing. So now we need to go back to our answer, and now we can say something like basin point sizes dot sort dot reverse dot inject. What? Okay. Oh, wait, what? No. Oh, dot take. We only want to take 3 of them. Okay. Whew. All right. That was like, it was simple, but it was a doozy to get through, right? All right. So now we should be able to run our height map thing and get back 1134. We do. All right. Whew. All right. That's working as expected. All right. Let's copy all of that input. And I guess to keep it easy, what we could do is just dump it all in here. Let's see, does that work? All right, 827,904, 827,904. Oh gosh, yes, we've got it right. And we got the basin points and we passed the test. Okay, all right, that was trickier to redo than I thought it was gonna be. The first time, yeah, I must not have been as tired or something, but this was tons of fun. Thank you so much for watching, and we'll see you in the next one. Cheers.